This is part 2 on trig identities, and what we want to do today is look at simplifying identities. So in part 1, we reviewed a whole bunch of identities that were all basically trig equations. And what I want you guys to realize is that each one of those can be used to do substitutions. So let's look at an example. If we take one of our identities from part 1, tangent x equals sine x over cosine x, I want you guys to realize that you can actually do two different substitutions because each equation works both forwards and backwards. So for example, if in one question you saw tangent x and you wanted to change it into sine x over cosine x, you could do that. And maybe in another problem, you did that backwards. You saw sine x over cosine x, and you said, oh, I can simplify that by turning it into tangent x. So each one is going to be used in a different type of question. The first substitution you might do if you were multiplying by cosine x, and you wanted to cancel those out, because that would simplify. The second one you might want to do for your final answer. If you end up with sine x over cosine x, you turn it into tangent x, and it's simplified. So what we want to do today, I'm going to give you guys some trig equations, some more complicated ones, and we want to simplify them as much as possible. So this will be our first example for today. We want to simplify tangent x times cosecant x. And when I first look at this question, I think, okay, there's not much of a relationship between those two functions. But one thing you want to remember, you can always change trig functions all into sines and cosines. Every tangent and cotangent can be written using your quotient identities, and every secant and cosecant can be rewritten using your reciprocal identities. So let's do that and see if there's any kind of relationship here. Let's take tangent x and write it as sine x over cosine x. And let's take our cosecant x and write it as 1 over sine x. There's two substitutions we can do. Now once I rewrite it, I see, okay, this does simplify because the sine x from the top and bottom will cancel. And now when I multiply, what I have is just 1 over cosine x. Now 1 over cosine x is one of our reciprocal identities. And that's what I'm going to give for my final answer, is secant x. That's as simple as we can make it. All right, let's take a look at another example. This example is a little bit more complicated. We have cosine x times secant x minus cosine x, and then the whole thing is over sine x. So I'm looking at this and I see those parentheses and I say I want to get rid of those first. Probably the easiest way for me to do that would be use the distributive property. I'm going to take this cosine x and I'm going to multiply it here and here. So what I'll have is cosine x times secant x minus, now when you do cosine x times cosine x, you get cosine squared x. And that whole thing is still over sine x. Okay, now I look on top and I think, well, I have cosine x times secant x. Those are actually reciprocals. In fact, if I write secant x as 1 over cosine x, rewrite the rest of the question here, then what happens is the cosine x cancels and just leaves 1. So what I have right now is 1 minus cosine squared x over sine x. So we simplified a little bit, but we're not done yet. Remember, we always want to simplify as much as we can. Now the other thing I noticed in this question, as soon as I multiplied the cosine x times cosine x and got cosine squared x, every time you see one of your trig functions squared, you should immediately think of the Pythagorean identities. That's when you can use them. And in fact, if you remember from part 1, 1 minus cosine squared x just equals sine squared x. So what we have right now is sine squared x over sine x, and one of those will cancel. Remember, sine squared x means sine x times sine x. So what I can do is basically cancel one of them with the one on the bottom, and my final answer is sine x. So this is what we're doing today. What I want you guys to do is take these trig expressions and simplify them as much as possible. I want to make sure you do know, though, not every answer is one single trig function. Both of our examples today simplified all the way down to one trig function. We had one answer that was just sine x and one that was, I think it was secant x on the first example. That doesn't always happen. It's good when it does, but just remember, try to simplify as much as possible.